Okay, so this is problem 21 on the complex problems. This is probably the hardest one on there. I would definitely just follow along on the video if I were you instead of trying this one on your own. Okay, so in order to understand this problem, you need this angle right here. Now, what I'm going to do is I'm going to draw a couple parallel lines and use a property from geometry class from last year, right? So last year you learned that if you have parallel lines and what we call a transversal, okay, then their angles are the same. So this is what we call, this angle right here and here is what we call that corresponding angles, because it's parallel, parallel, transversal that goes through. So this guy and this guy are corresponding angles, right? Now, imagine me taking this piece right here, this angle right there. And we know this is a 90, right? We know that's a 90. So what I'm going to do is I'm going to grab that piece right there. No, not that piece. That piece, and I'm going to turn it 90 degrees. Would you look at that? It lines perfectly right up there. So, essentially, if I could find this guy right here, I actually found that guy. It's a 2-for-1. So that's what I'm going to try to do. I'm going to try to find this guy right there, and then I'll have the answer for the other. So here we go. How are we going to go about doing that? A couple triangles. So I'm going to erase that. That's the general idea of how we're going to get there. How we're going to need to get there is a little bit harder though. Okay, so if you look at this, this is kind of set up to where this is actually a rectangle right here, and it's not a bad drawing on my part. This is a right angle, that's a right angle, right angle, right angle. Okay, that's a rectangle. And notice it doesn't hit the center on this big circle right here because this diameter is larger than this diameter. So therefore, we know that their sides are not going to be equal if you went all the way to the center. So I forced them to be equal like this. And if you think about it, now I can do a little bit of math here to figure out what their side lengths are. Now, so if we were to go, let's see, if we were to go all the way here, right, going all the way here and over, this distance on the side would be half of this, which is 0.375. And over here is half of this, which is 0.3125. Yes. Okay. So that tells me there's a little gap. You see that little gap right here? There's a little teeny tiny gap right here. Okay? And I can find that little teeny tiny gap by subtracting this value from this value to find this little tiny gap of this triangle. So I have a triangle, little tiny gap, long diagonal, and then straight back. I know that's not drawn really well, but that's the idea. So how do we find that little gap? Well, here we go. We're going to go 0.375 subtracted by 0.3125, and that's going to give me, what is that going to give me? It's going to give me 0.0625, okay, which is the size of this little piece right there. All right, so that's going to be one of my triangles. I'm going to kind of flip it over and draw it the right way so I can see it a little better. More exaggerated, but that's the idea. So this distance is 0.0625. Okay. Now, on my diagonal, okay, or on my base, from the base of this triangle right here to the base over here, I know that distance is this. So I'm going to write that down. That's 1.312. Okay, good. Now, all we have to do is find this distance right here. I'll call it x. Okay? I'm going to use that distance x. Okay, actually, well, you know what? Actually, I don't even need x. What I want the angle. I want the angle. All right? I want this angle right here. I want that angle of that teeny tiny triangle. So I'm going to try to find this angle. We'll call it theta. Well, that's opposite over adjacent, which is tangent. So I'm going to go tangent of my angle equals opposite over adjacent. So that's 0.0625 divided by 1.3125. And if you have to pause this video at any time to try to keep up, because I know I'm moving kind of fast, feel free to do that. So inverse tan on both sides. I should cancel these guys, leaving you with a theta over here and giving you an angle of angle of 2.727 degrees. Okay, so if you think about that in the context of our problem, that's this teeny tiny angle right there. Teeny tiny angle. Now it's not the whole way down, it's just a part of that thing to make it square. So we need this guy. This guy is important. All right, now, what's the next triangle we're going to find? The next triangle we're going to find is going to go from the center. You know, I'm going to clean this up a little bit. Okay, I'm going to clean this up a little bit so we can see a little better. So we're going to go from this center all the way over to the edge, make a 90, bounce back up, close it. Okay, so we're looking for that now. Okay, now I know Well, let's see, what don't I know? I know that this distance, okay, right here, is going to be this number minus this number, which ends up giving you a 0.595. Okay, so that's that distance right there. This guy minus that guy gives you this guy. All right, we don't know this guy. We need to find that guy. And we can find out this side right here. I'll call this, we'll call this Z, I guess. We can find Z by finding Z here, which I'm just going to use Pythagorean theorem because it's just as easy. Okay? So Pythagorean theorem tells me that if I go a squared plus b squared equals c squared, so Z is equal to the square root of 1.312 squared minus, well, let's see, plus 0.0625 squared. Okay, so we're going to work that out. If you work that out, you get it. You end up getting Z is 1.312 or 313. Okay, so that is the distance right here, which happens to be right here. Okay, so 1, 2, 3. That's how it goes. Okay, now we got to find this x value. So, oh heck, I don't even think I need to find that x value. I don't need it. I just want this angle. Yet again. So if you look at this red triangle here, I need this angle. Hey Frankie, I need you to be quiet. Alright? So, I need that angle right here. So, let's see if we can work this out. So, this triangle looks like this. Okay? We know this side is 1.313. We know this side is 0.595. So, that's pretty good. So, we need this angle theta. Okay? So, I'm going to use an inverse sine there because I have an opposite and a hypotenuse. So, an inverse sine of 0.595 divided by 1.313, and that will give me, that's theta. Theta will be 26.947 degrees. Okay, good. Now, I think we're just about done. So I'm going to redraw this a little bit. So we have this angle right here. We have the red angle. Right, on the red triangle, I'm going to draw the triangles for you. We have a red triangle and we have a green triangle. Okay, those are our two different triangles. Or no, we have a red triangle and a blue triangle. So this is one guy, and then we have the red triangle. So I'm going to show you where those are on the triangle. The blue triangle goes like this. It goes, well, let's see, it goes like this. It's kind of set up like this. That's the blue triangle, and we have that angle. And then we have a red triangle that goes like this. And that's the red angle. Okay? So what we're going to do is we're just going to add those two together, and we should be good. We should have our angle x. Because remember, we said in the beginning of this problem that this angle matches this angle, and that angle is that angle. So essentially we have it all together. So we just have to add these two guys together and we're done. Alright, so adding them together, we got 26.947 plus 2.727. Work that out to be 29.674, and that should be your answer right there. That should be angle x. Angle x should be right there. Again, very, 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 very difficult problem. Probably the hardest one in this packet for sure. Kind of hard to see those pieces, but that's where it all comes together right there. Okay, good luck with that.